I've finished the internal wiring on the case. Looks a lot better now. All the white wires have been collected and terminated on the neutral side of the IEC connector. The hot side of the IEC connector has been brought out to this switch and then taken back to all the black wires on the power supplies. I've connected, now there's two power supplies stacked vertically here. I've connected them top to bottom in series and tucked them away in these green shrink wrapped connections. I'm looking at this set of wires now on the meter, and if you look carefully, there's an LED here. There's actually an LED on each power supply. A little bit of startup time, and the two 16-volt units are supposed to make 32 volts. They make 31.5. And the other one, that is the other pair of power supplies, is 31.62. Now there is a bit of a delay, but watch the LEDs and listen to the click of the switch. Just a little bit of time there before it comes alive. Switching power supply manufacturers, when discussing connecting their products in series like this, say that's fine. But they do recommend connecting from plus to minus, or that is connecting across the output, a diode, the same as I propose to install here, across both outputs. In our case, 4 outputs, but anytime two switching power supplies are connected in series, they should have a reverse voltage protection. In case the startup delay on one of the power supplies is much longer than the other. If one of these starts up first and the other doesn't, and they're connected in series, we can reverse bias the one that's not powered up, the one that is delayed in starting. And that reverse bias can damage the filter capacitors on the output of the slow to start switching power supply. I've never done that, although you can see where there's a little white, where I've whited out. I was going to do that. I've done this many times, never had a problem. But be aware that the manufacturers would have you connect some diodes across the output. I'm going to prep the front panel now, really the back of the front panel. And the first thing I did was to install the diode across the output jack. I made good mechanical connections. That is, I didn't solder them yet, but these are 3 amp diodes with really heavy wires. Now the reason for the heavy wires is normally the heat sinking ability of the wires. We don't need this heavy of a wire to carry 3 amps of current. My intention then is to use these heavy wires to connect in parallel with the diode a 0.1 microfarad 500 volt ceramic disc, and I'll connect this in parallel just using the leads on the diode. And I'm going to put a 22 microfarad 50 volt capacitor across the output as well. Although I may rethink the electrolytic, I might go down to a 10 microfarad. Supposedly these buck converters are current limiting. If on the output terminals I put a really big filter capacitor, that means there's a lot of stored energy after the current limiting feature. So I don't want a really big capacitor, electrolytic capacitor. But I don't know, I feel I need something. Well, let me go back and check, and if I have a 10 microfarad at a voltage that I'm happy with, maybe I'll install it. I soldered the electrolytic capacitor. Somewhere in there you can see maybe the little ceramic capacitor and a red and black wire to each banana jack. Now I didn't install the buck converters because I wanted to be able to work around here. The buck converters now, and while I'm here I guess I'll explain that the one without the fan is a 2 amp buck converter and it's enclosed back. And the one with the fan is a 3 amp buck converter. Now I've seen these advertised as 5 amp. I've seen these advertised as 3 amp. But reading the literature or the eBay seller's information, it seems as if the 3 amp always has a fan. And if you take the fan off, or if you buy a 2 amp one, so this is a 2 amp one, that makes it a 3 amp one. But not every 2 amp one has fan headers. The wiring from the banana jacks just goes across the bottom of the front panel into 2 of these 4 screw connectors. Now the power switch installs from the back, so we don't need to worry about that. These red and black wires are very short and lay across the bottom. So I'll keep these wires fairly short. There's no reason to heat shrink them or anything. It's my preference when going into these Chinese screw terminals to tin the end of the stranded wire. American-made screw terminals will accept stranded wire fairly safely. The Chinese ones seem to be either poorly designed or lack the metal that it takes to clamp all of the conductors. The wiring's complete. I've powered it up and the power supplies come on. That is, the buck converters come on. One last thing, now I've narrowed the template by 1/2 millimeter, but if these, or any time you run into this situation, if these grippers on the side of a panel mounted device, if the opening's too wide, and in this case it was, stuff a toothpick down as a wedge and it tightens it right up. I made sure that the wire is dressed away from the fans. Simply turning it on doesn't cause the fans to run. They're thermostatically controlled. Here is the completed in-case power supply. Feels heavy. Feels solid. Now this case is held together with 2 machine screws going into brass inserts. Pretty quality made case. I think this costs $11 or $12. And there we see it booting, each power supply that is, and then it goes to a display. Looking at the right hand power supply now, and you'll see that it's set for an output of 5 volts. And it is outputting 5 volts. The load is on. I can turn the load off. And it is in the constant voltage mode because the drawn current, the current being drawn, is less than the set point. If I push set, now it's energized. The load is energized, that is. I'll push set once. An underline appears at V set. If I push the down arrow, the underline goes to I set. If I push the detent on the switch, it goes to the first digit of the current. Push it again, it goes to the second digit, and once again it goes to the third digit. It wraps around the first digit. Now the dummy load is drawing 0.96 amps. I'm going to lower this to 0. I'm going to move it over to the second digit and increase it to 500 milliamps, or half an amp. Now remember, the dummy load is set to draw 0.96 amps because the output current I set is set for a 500 milliamps limit. I out is limited to 500 milliamps. Now I can increase the output limit. We're in the constant current mode now because we're trying to draw more current than what the set point is. Now when I get up around 9, it's not quite ready, but when it rolls over to 1 amp, that is when the output limit is set at 1 amp, and the dummy load is set for 0.96 amps. If I decrease this current output setting, the dummy load's still trying to draw 0.96 amps. The power supply goes into the constant current mode. If I increase the current output limit, we now go back to what the dummy load wants. And we can do all of this on the fly with the load energized. We can de-energize the load, and we're still in the adjustability mode. Once we're happy with whatever we've set, we can just push set. My intention is to leave it in this configuration, which is this power supply is set at 20 volts. The load is powered. Its load is this dummy load, which is drawing 2.5 amps, which is reported on the power supply as being 50 watts, which, according to the bench meter, this is 19.97. So that's close enough to 50 watts. The other channel is hooked to a set of JBL speakers, stereo, with internal amplifiers. These are throwaways from a computer. I have the audio input to the speaker amplifier shorted out. This power supply is set for 12 volts, which is what the speaker requires. It's turned on. The output is going to my voltmeter. The voltmeter is set for AC volts. And it is going to an oscilloscope as well. I intend to let this run for 4 or 5 hours, maybe overnight. I'll do a final video, assuming it doesn't catch fire. I'll show you the voltmeter and the oscilloscope, and you can decide for yourself how the system works. If you've enjoyed this, and if you like this kind of stuff, Give me a thumbs up, subscribe to my site. If you can think of any more ideas for different videos, drop me a message. And thank you for viewing.